I do love water. I love to swim, to surf, and even to drink water. And do you know why I do love water? Because I am water. 2/3 of our body is made of water. And because of that, for the last 15 years, kind of since high school, I have been studying water. And I have a secret to tell you. Water is weird, pretty weird. Okay, it's weird, but also is fundamental for our lives. And fortunately, 70% of the planet is covered with water. But unfortunately, just 1% is clean water. 1% is water that we might be able to drink. And that's too little. Today, 1 in each 6 people have lack of fresh water. And in the year 2050, will be 1 in each 2 people with lack of fresh water. Either you or me will have lack of fresh water. So the world needs fresh water. Please, don't panic, because today I'm going to tell you how we can use the weirdness of water to help us to get more fresh water. So you see, water is very important. But when I tell people I work with water, they usually say to me, well, such a simple molecule. We know everything about water. Even my mom tells me this. But that's not true. Water is not simple, and you have many things in water that we need to understand. Okay, you're not convinced? Let us compare water with another material, with silicon. Silicon is also abundant in the planet. 28% of the Earth's crust is compounded of silicon. And silicon also have a number of unique properties. And the fact that silicon have unique properties and that we have learned how to use these unique properties of silicon allows us today to have cell phones, computers, flat screen, and all these instruments that are govern our lives today. And you know what? Silicon has just a half a dozen anomalies. Water? Water have 70. Yes, 70 anomalies. So it's our duty to find ways to use these anomalous behaviors of water to have more clean water. So how we are going to do that? But before answering this question, let me introduce to 2 of the 70 anomalies of water. The first anomaly is the density anomaly. Most liquids contract upon cooling. Water does the contrary. You cool water and it expands. And that's why ice that you're seeing in the screen floats into liquid water, because ice occupies more volume, less dense, and it floats in the liquid phase. But much more interesting than ice floating into liquid water is the fact that 0 temperature water floats in 4 temperature water. See the beauty. When you have a winter in the North Hemisphere, you have ice, followed by 0 temperature water. And found, in the bottom of the river or lake, you have the warm 4 centigrade water with the fish and plants surviving. If water would be common as other materials, in the first winter, in the glacial time, it would frozen from bottom to top, and all the life would be killed. It's not that cool, literally cool. So now I come with the second anomaly. The second anomaly is the diffusion anomaly and is related with mobility. Water, when it's more dense, is more compact. The molecules, they move faster. Okay. Marcia, you're saying something wrong on that. I know that when I have more cars in the traffic, the cars move slower. When I have more people in the shopping center, people move slower. Water, when you have more water molecules, they move faster. It's not that bizarre. So, come on, what's the mechanism for that? And for that, I'm going to give you just a little class of physics. So water is compounded by an oxygen, the big I, and two hydrogens. And inside the molecule of water, the interaction is the covalent interactions. But between molecules, you have a second interactions, that the hydrogen bond interaction. So what's the difference between the two of them? Covalent is very close, is very strong, and is very tight. Hydrogen bond is further apart and is 20 times weaker, okay? So covalent bond is like marriage, or like marriage was supposed to be. You know, the particles are moving together and they're very tight. Hydrogen bonds is more like flirting. You are more distant, you flirt here, you flirt there, you flirt everywhere. Okay, now I got it. When I decrease the temperature and I have ice, I have all the particles together and all the hydrogen bonds made, so I am further apart, like frozen. I don't move, but I have the hydrogen bonds. I hit a little bit the system, I broke the bond, and particles actually can approach. And that's why ice floats into water. But how this increase mobility? Easy. It's easier to flirt in a crowded party than to flirt in an empty party. So water molecules actually move around when they have more particles, making bonds, disrupting bonds, making bonds, disrupting bonds. It's not that cool? But you know, not always hydrogen bonds are a good thing. This deep and great love of water of making bonds might make water end up in bad company. Water might make bonds something that's poison to us, or something that makes water undrinkable, like salt. So the bonds are not always a good thing. And actually, the industry uses this property of water of making bonds as to throw away the waste or to produce things. More industry, less clean water. More people, more need of clean water. So now you can see why in 2050 we are having you without clean water and me with clean water. You know, because we need new scientific methods in order to get more clean water. And there is where the anomalies of water come about. In years ago, we have found that the very same mechanism that makes water to move faster, to diffuse faster, also makes water to flow faster when confined in nanotubes. Let me explain what I mean faster. In nanotubes, water flow 900 times faster than would flow if the laws of physics that govern the sink of our house would govern the nanotubes. So water loves to be in these nanotubes. It enters and just ballistically flow. But salt doesn't. Salt hates nanotubes. They have to undress the hydration shell of water to get inside the tubes, so they don't like nanotubes. So now, if you combine the love of water for nanotubes and the hate of salt, you have thousands of nanotubes put together as the perfect filter for desalinating water, the water that actually you have in abundance in the planet. This is a possibility, a clear possibility for the future when nanotubes becomes an industrial commodity. Great! However, and there is always a however, I don't live close to the sea. So how can I get more fresh water if I don't live close to the sea? So a few months ago, when I couldn't sleep and I was surfing the internet, seeing weird animals, etc., I came about with this beetle from the desert of Africa. This animal is capable of capturing the vapor air, transforming liquid water, and drink it. Come on, how this animal does that? In the back of the animal, they have an upper surface in which they have molecules that love water. And they love so badly that they transform vapor into liquid, what actually requires energy. And then they have a second layer that hates water. So when the particles, liquid water, comes to the second layer, they just slide as the water is spilled in your sofa that you cover with the polymer surface to avoid to be wetted. And then the animal is so smart, this beetle, that he just leans to the front and the water just comes directly to its mouth. It's not perfect. Nature is perfect. So now our group is developing a combination of the two mechanisms. We have nanotubes in water, flow fast, and the top of the nanotube loves water, and the down part of the nanotube hates water, and we are going to use that to transform vapor into liquid and to storage. So stay tuned, and years from now, water in nanotubes will solve the problem of lack of fresh water in the planet. Thank you very much.